Hello everyone. So today we are going to do Leetcode daily challenge merge case sorted list. So basically in this list, as per the question, we would be given case sorted list and we are required to merge all these lists into a single linked list. So this is the question which are being given to us here, and here k simply represent the number length of the list vector which is being given to us, and then we could assume that the maximum length of any linked list being given in this list a vector of linked list is simply n. We will be assuming that. Now comes the part of constraints. So here constraints are like our k is simply equal to 10 raised to power 4. That is, there could be 10 raised to power 4 linked list in our vector of linked list, and then size of each linked list can go at max 500, right? And then this is same thing only. Means this 10 raised to power 4 and this 10 raised to power 4. This is same thing only, that maximum 10 raised to power 4 linked list could be possibly in our vector. So this is all about the constraints which are being given to us. Okay. All right. And as per the constraints, we can see that if we devise a solution which is uh, in the form of n cube or n square, something like that, where n simply I want to say about the length of the linked list, means basically a solution which is of this type, means length 500 in 500 into 500 into 500, something like that. But here, as uh, we are required to consider both the length also and even, means length of maximum length of a particular linked list also, and even the number of linked lists being given in our vector of linked list. So according to that, we are required to devise a solution. Now here comes the part. For that particular vector, we could devise solution. So here one solution could be by taking a priority queue, which would be simply of order of n solution for space complexity if we take it into consideration. Basically not order of n but order of k. And then one solution could be without any auxiliary space, but that would be by using divide and conquer method. Now comes the part of the priority queue solution first. How we could use a priority queue for this particular thing is, okay. So the thing is, we are given with these lists, right? Here k value simply equals to 3, right? And the maximum length, that is n equals to simply 3. That also 3. Here minimum is 2 and maximum is 3, right? So how we can use a priority queue is, we'll simply insert all the heads of these linked lists into our priority queue at a particular time, and then we'll simply compare them, and then in our priority queue it will be simply in this form, right? It will be in ascending order only, means already sorted, and then we'll create a new linked list which will be starting from 1. We would be having a dummy node D, and after that we'll simply insert 1 here, right? And then after inserting this one, whatsoever is next to that particular linked list, we'll insert that to our priority queue again, and we'll pop out this one. Means we'll either, that one could be from this slot or this slot. That is not our concern. It could be anyone. Let us see. Let us take this first one only. So it will be inserted here, and when it will sort, then it will be at the last only. Then again we'll traverse in this priority queue, and then we'll simply pop this one and insert this one's next element, that is now 3. 3 would be inserted, right? So it will again sort, then it will become 2, 3, 4, right? Like this only, we will be simply having at most k elements in our priority queue, because we are considering these k linked lists at a time only, right? Means at max we could have these k linked lists, but the iterations which we will be taking for this priority queue could go n times, right? Because we are required to finish the longest linked list also that is of size this, right? So that's why at a particular time in our priority queue, we would be having just k linked list in it, right? And then we are required to insert into it, right? And when we would be inserting, we'll simply pop out the smallest element which is there at the top, and we'll simply insert toward this linked list. And by this, we would be simply able to have all the elements which are there in sorted on order, right? Means then again this 3 and 4 would be inserted and all those things would be done, and thus we would be having a linked list in such a manner. So like this we can simply have our solution where we are using priority queue and we are simply inserting it. Okay, so let me explain you with this code. So what we are going to do is, because we are having a priority queue and we are coding in C++, right? So we would be having our max heap as by default. Okay, wait a minute. Just forgot that. Is it the max heap or so in C++, our by default it would be, so in C++, by default, as it would be in, because we are required to simply compare it, right? So we'll simply make a comparator function where simply we would be having this one, because our in C++ by default we are having a min heap only. So that's the reason we are required to have a comparator which will simply do our reverse our operations. So in our linked list, when it will be having the highest value, right, means it will this comparator struct comparator will be simply returning in descending order only, right? And when it returns in descending order, as our heap is by default mean heap, so it will simply reverse the operation, and thus it by then after all it will be simply in our min heap solution only, means in increasing order only it will be sorted. And here we are taking a dummy node, and here we are simply taking a dummy node because we are required to make a new linked list, then taking a current node where it will simply keep the count of the present hit which we would be having from our dummy node. Then here what we are doing is we are simply inserting all the heads of the all linked list into our priority queue, right? And after that, what we are doing here is we are simply whatsoever we are having at the top, right? Means the smallest element whatsoever we are having, we are simply making a linked list here, that is current node next equals to heap dot top, that we are doing here means making a linked list, and we are simply popping out that particular element from our priority queue, right? Then we simply pop out that, and then what we do, we'll simply go towards the next, means simply change our current node. Now our current node is simply, earlier it was 0, right? We have made zeros next equals to heap dot top. Now our current node is equal to current node next, so now it has become, it will be now 1. So we'll check that if our current node next, means basically if our present linked list do exist, right? Then at this particular moment, what we would be doing is we will simply push this current node next into our priority queue, and then we would be having a new element in our priority queue, and thus we'll again run this particular loop, and this would be run until our heap simply becomes null. And because of this fact only, we would be able to merge all the linked lists which are being given to us as an input, and then at the end we would be simply returning head dot next, because our head was simply equals to 0 because of this dummy node, so that's why we would be returning head dot next at the end. Because we are using a priority queue, and at max a priority queue would be having k elements in it, right? We are taking here k also, and this priority queue would be having k elements at max in it. So that's the reason the space complexity would be simply order of k only, and the time complexity will be simply n into log k. Why log k? Because in priority queue it will be sorting k elements, and sorting takes log k time, and because there could be at max n elements, so that's why we are taking a time complexity as n into log k. So that's the time complexity for this particular solution, and space complexity as k. Now come we see next part, that how we can improve this particular solution. We can simply improve this particular solution by using divide and conquer method. And when we would be using our divide and conquer method, then in that particular fact, we don't require any auxiliary space. So this is how we can do. Um, so the thing is, we are given with this particular input, right? So how we can do is, we can consider we can consider this particular list, right? Means our list would be there. Let us say it as 0, 1, 2 for the linked list being present in it. So what we are required to do is, while okay, the main concept here is that what we would be doing, we'll considering 0 and 1 list, right? So when we consider 0 and 1 list, then we would be simply merging them, right? And when we merge them, then we would be having some other list. Say 0 we have merged, so we would be having some other list, right? So we will merge then 2 with this particular list, and at the end we'll simply return this particular as our answer. So while doing this particular process, what we are doing all over here is that at this particular portion at max n elements are being considered. At this particular portion again at max n elements are being considered, right? And because we would be simply making all these elements into further single elements only, and doing this particular part will simply take us to k into log k time. How it will be taking k into log k time is like, we are having this list 1, 4, 5, right? And then we are having this list 2 and 6, right? So what we would be doing is, while merging we'll simply check 1, and here it 2 would be check, whichever is less than we'll simply consider that, and the next would be simply in our loop only, and then what we'll check for here 4 and 2, right? Then again we'll simply have this 1 and 2 is there, right? So now 2 was being considered, so now it will be simply checking for 4 and 6. Now again it will check for 4, right? Now 4 is being considered, so it will simply check for 5 and 6. Now 1, 2, 4, 5, and then at the end 6. Means how we are doing is, we are simply using the concept of divide and conquer, that we would be simply having this 1, 4, 5 and 2, 6. At the end they would be simply at such a position that all are at individual levels, and we are simply merging all those individual elements together, and as they are individual elements, so that's why it will be at a particular stage that they are already in sorted manner only, means all together they are sorted, so we will be simply merging them. So that's how by divide and conquer we would be simply doing this particular solution. Now uh, let me show you, let me first show you that how the code would look like, and then I'll simply show you with the dry run of that particular code. So while doing the divide and conquer method, we could simply see that this particular question, this particular question of merge k linked list could be simply converted, means this merge k linked list could be simply converted to merge two linked list also, right? So while doing this particular thing, what we can do is, so this is the code for simply merging two lists, right? That's how we can merge simply two linked lists. And here the thing is for merging of k list. So major work comes up here only. First we are checking for that if list dot empty, right? Then we'll simply return null. That is we are not required to merge any of the lists. So our answer would be null. Then here, what we are doing is we are simply considering k equals to list dot size k greater than 1 and k equals to, we are simply doing it half, right? That is first k elements would be, k list would be considered, then k by 2 list would be considered, and then k by 4 and so on. So that's why this particular loop would simply run log k times only. Now we are considering one more loop inside it. This particular loop would again go from 0 to k by 2. That is, now this loop is going from k by 2, then it will go from k by 4, then k by 8, and so on. And this will be going like this. But overall, it is simply order of k only, because it is only changing because of this outer loop only, right? So that's why now comes the part that this particular thing would be doing, that it will start from the list size, that is this list size which is simply equals to 3, that is 1, 2 and 3, this list size. It will start from this, it will divide itself turn by turn. Why I am dividing is so that in this particular portion what I am considering is, I am considering the first element and the last element, which last linked list which I am having. I am considering only these two linked lists only. So that's why I am dividing this particular, because whenever I will simply iterate again, then my linked list of I, that is my linked list of 0, it won't consider this particular portion. Means it will consider till half of the linked list only. Means first half would be considered, right? And the second half won't be considered, this particular thing. So that's why I'm simply dividing it by 2, so that only first half is taken into consideration. Basically um here the thing is that due to this the second half would be considered, but due to this the first half would be considered, but only for that particular portion. Means because it will be simply dividing it, right? So that's a, that particular, this particular second half would be considered. Means here it is discarded, right? But when it will be simply doing k plus 1 by 2, right? So if it was, let us suppose not take, because this is a smaller example, let us take this 5, right? Then it will be doing half, then at the next moment it will be at 2, right? So our k would simply start from 2 and it is still greater than 1, right? So that's why this particular portion will consider r 1 to 2. Earlier it was considering 1 to 5 linked list. So that's what I was explaining. Now this next particular thing is, int I is equal to 0, I less than k by 2 and I plus plus. Because of this I, we are considering this particular first linked list, right? And because of the k value, because of this particular loop only, we are considering this particular and this particular. Means earlier I was considering the last most, now I'm considering the middlemost linked list. So this is how it is. The choice of these two loops are letting me take the linked list, choose the linked list wisely. And here linked lists are simply made in such a manner that they are not creating a new linked list, they are simply changing the linked list which is at the first, means which is already exists, which is the input linked list itself. So here comes the part merging of two lists. Now this merging of two lists is simply that question only, merging of two lists. And in this, how I am merging this is, I'll explain this with that recursive call diagram. But here let me show you that what I am doing here is, so here I'm considering if my list one do not exist, right, then I'll swap the list so that I could simply compare the list which do not have any node, because we can easily compare nodes, linked list which do not have any node and other linked list fully placed there, right? So this thing I'm doing here, then I'll simply swap the list. Or if my list 2 exists, right, and also my list 1 value is greater than list 2 value, if that is the case, because we want every element in ascending order only, right? But here the case would be that the now elements are simply in descending order, right? So that's why we are simply swapping at this particular moment also. Now comes the part that list 1 and list 2. If list 1 exists but list 2 do not exist, then at that particular moment we'll simply return list 1. But if our list 1 do not exist and list 2 exists, then at that particular moment we'll simply return list 2. So this is for the case so that we could simply exit that um, earlier than expected. So for that condition, I've considered this. If we don't consider this also, then also it won't affect our overall solution, but it will affect just somehow affect the time complexity, not much. Then comes this part, that is if our list one exists, right? Then here we are simply creating our linked list, means merging our linked list here. We will simply do list one next equals to merging of two linked lists, that is list one next and list two, right? And then at the end we will be simply returning our list one. So this is all what we are doing in this merge function, right? And now at the end, this particular function will return whatsoever list is being created to this particular list of I, that is list of 0. Now at the first moment, if I consider this 1, 4, 5, then it will simply return this particular 1, 2, 4, 5 and 6, right? Now our list of 0 would be having this value, and then k value is simply changed, and now our list of 0 is simply this, and our list 1, which is simply 2, 1, 3, 4, 1, 3, 4. Now both of these lists would be simply sent to this particular function, and then again it will be merged, and after merging we'll get our final answer, that is this one, because we are at the end returning list of 0, right? So whatsoever is being uh, changed, it will be changed in our first linked list itself. So this is all what we are required to do here. Now let me explain you this solution more clearly. What we were doing was by doing the dry run. So what we were doing was like this, that first our key value is 3, means I'm taking this example only. Our key value is 3 and value is 3 and at least value is 2, right? Then when k is equal to 3 and I is equal to 0, means at this particular moment only I equals to 0 and I is less than 1, right? Why 1 I'm saying, because k value simply equals to 3 and 3 by 2 is simply 1, so that's why. So our list of 0 is equal to merge list of 0 and list of 2, right? This we will be sending in this merge to list function, and then what we are doing is we'll simply check for all these conditions. This condition is true or not true, right? So there won't be any swapping. And then this particular condition is true, right? So that's why it will start making the linked list. Then after making the whole linked list, it will simply return this particular linked list to our this particular function. Now comes the next part. Now k becomes 3 plus 1 by 2, that is 2, right? And I simply equals to 0. It will always start from here only. And then I simply less than 2 by 2, that is 1. So yeah, this loop will run. And at this moment, list of 0, that is I, list of I, which is equals to 0. List of 0 is equals to this. It will simply call our this merge to list function. And here list of I, that is 0. And then list of 1. how it comes out that k minus 1, that is 3 minus 1, 2, 2 minus 0, that is, moreover here k value has been simply changed, right? Here k value simply equals to 2, so 2 minus 1 be 1, and 1 minus 0, that is now list of 0, 1, right? So at this particular moment, uh, we will be sending a list of 0 and list of 1 only, right? And now we will be simply sending, so this doesn't become true, so no swapping comes into consideration, and then this becomes true, right? So it will start making its linked list. So after that, basically till now I was telling the overview of this function, means only this function only I was telling, and now it will simply have this particular linked list, and till this moment we would be having our whole linked list with us, because list 1 means list 0, list 1 and list 2 all are merged. So till now we would be getting our answer here, and then it will again check k is equal to 2 plus 1 by 2, that is 3 by 2, that is 1, right? So k here becomes equals to 1, and here I'll list even it will be simply there. So here it won't satisfy this particular condition, right? So it will simply return list of 0. So our answer would be returned at this moment. So all of this was I was explaining for this particular function. Now comes the part for this merging function, merging two list function. Basically, it is a separate question also, but still, I would like to explain you here that how that particular function is working. So the thing is, now here, this particular, let us take this example, 1, 3, 4, and 2, right? So, list of 0 is here, 1, 3, 4, and list of 2 here is 2, right? So first, it will check for this particular condition, which is not true, so no swapping takes place. Then we consider this particular condition, list of 1 is list of 1, yeah, list of 1 do exist, right? So it will see, list of 1 here is list of 0, next equals to, then it will call this merge function, right? And then it will send list of 0 next, which is now 3 here. Earlier it was 1 because it was starting, but now once next is simply 3, and list 2 is equals to 2, right? So what it will be doing is, it will be sending both of them to our merge function, right? So now it will check for next condition that two list of 0 exist. Yeah, it exists. But at, it will check now that if the present value, that is 3 and 2. Is 3 greater than 2? Yeah, it is greater than 2, right? So now swapping will take place. So now our list 0 is simply swapped by list 2, right? And our list 2 is having value 2, and 2 is next equals to merge list 2 next and list 0. So list 2 next is simply equals to null, because here we were having nothing in this particular linked list, right? So list 2 next is now null here, and list 0, that is 3, right? So uh okay, so list of 0 which is having the value as 3 here, right? Now this list of 2 doesn't exist, right? Because it has become now null. So now swapping will take place, and when it is swapped, now list of 0 comes into consideration. Now it is having value 3, means it has taken its value from here only, and now its next would be taken here. And then we'll call our merge function. Then list of zeros next, that is 4 which was there, and list of 2, that is null. These things would be there, and then a list of 0, that is 4, it will be here, and then it's next, we'll take for the merge function, and here both of them are now null, right? So it will simply return our list of 0. Then it returns list of 0, because list of 0 has now pointing towards null, so it will simply return null to its calling function, that is this particular function, right? And now it is having the value null, so list of 0 next equals to null, that is 4 next will be equals to null, right? Now this 4 point 4 with null, right, means this particular linked list. Now it will be simply answer to the calling function of this, right? So now this calling function will be having this 4 pointing towards null as the answer, right? So now here 3 pointing 3 is next will be simply equals to 4 null. That is 3 will be simply pointing towards 4 and null. Now this is our new linked list. Now this will simply be answer to this calling function. So now this particular will be simply answer to this calling function, and likewise it, this particular would be done. So this was in the starting I was telling that how we are doing is we are simply dividing a large linked list into simply some smaller nodes, and while doing so we are simply sorting it, and this is how while dividing it into various nodes we are easily able to build up a linked list which is simply in ascending order. And how it was working was because of this particular code of line, this particular condition. See, if we hadn't put this particular condition here, right, if you have put this in less than, then surely our particular linked list would have been in descending order. But as we have put this particular condition, that's why we are having our linked list in ascending order. Because we are simply swapping the list if we encounter any of the node in our list one as the decrease decrease means greater than the list two node. So here we are simply keeping a check here. So that's why we are simply making a linked list which is in ascending order. So now overall time complexity is simply order of n into k into log k. How that is possible? Because of this function which is of order of n, then this particular loop, because it is dividing itself into log k times, right? So that's why it's log k, and this particular solution, it is of order of k. So this is how the time complexity is simply order of n into k into log k, and the space complexity, as we are not taking any auxiliary array, so that's why either array or any auxiliary space, so that's why it's order of 1. But if we want to consider a recursive stack, so our recursive stack would be having k into log k elements, right, at max, right, because of these two loops only. So that's why in that context our uh, space complexity would be simply k into log k, and here n simply refers to the size of the maximum linked list. So this was the overall time complexity and space complexity of this particular solution. So this was all for it. If you have any doubt, you could comment down. So thank you.